So, in this video, we're going to be diving into some metal fabrication and some welding. A lot of welding, to be honest.
So I got this here new work truck with a flatbed, and I need to customize it or add some things to the bed to make it more suitable for work.
So, the design for this project was to create a carpenter utility style truck bed that consists of a ladder rack, some toolboxes, and some sidewalls that fold away so I can put pallets of material on the bed of the truck.
So I decided to start with the most easiest thing to do, which are the stainless steel hinges for the aluminum drop sides.
And what I'm referring to is this example here. These are drop sides. These hinges are composed of three parts: 1/8 inch stainless steel plating, 5/8 round stock, and 7/8 hollow stock. And basically, the hinges are created by the combination of these three parts, two of which will be the hollow stock welded to the back plate, the plating, which are created in two parts, which will then articulate through a center shaft. After everything is cut to size, the next step is to mark the holes for the drill press and then get everything prepped and ready for welding. And this is the part where, for me, I believe was the most interesting part of this process, is because I did not know how to weld stainless steel, and this is the only way I can figure out how to weld, by just welding, just practicing. So I have everything tacked here. As you can see, these are just the two parts of the hinge, and now I'm just gonna weld the mounting plates fully. So it seems that I made an error to couple of the sizes for the stainless steel hinges for the aluminum drop sides because I'm predicting the whole layout, um, not really making a whole, how you say, a blueprint. Um, Later on, once I made the actual aluminum drop sides and I saw that the articulation of the drop sides would not fold correctly because of the previous stainless steel hinges, I had to increase or create new hinges that were at least 3 inches longer in order to fold correctly. So that's what I'm doing here. Just the same process as before, but just had to redo it. However, this was a an opportunity to practice more stainless steel TIG welding, so nothing too bad came out of it. So now that I have the stainless steel hinges out the way, the next phase of this project was to create the main frame of the aluminum ladder rack. So as you can see here, I have the materials. It is just 3 by 2 rectangular tubing and it's 1/4 inch thick. This is some pretty heavy duty stuff. It's pretty heavy. Alright, so the next step is to start marking everything and cutting it to size so I can start prepping it and start to weld. So yeah, this measuring and cutting took the most time because to be honest, you have to measure 4 to 5 times before you cut it once because this stuff ain't cheap. And if I can give anybody some advice to somebody doing something similar to what I'm doing here, is to get you one of those angle finders like I have here because it saved me a lot of time and effort throughout the whole cutting procedure. So, yeah, good investment. So the aluminum ladder rack will consist of two parts. The first part will be the main frame that runs parallel to the surface of the flatbed and runs um, over the top of the cabin. And the second part of the ladder rack will be the legs that elevates the whole mainframe of the ladder rack. So in these shots, I am cutting every component that will be part of the main base of the main frame of the ladder rack. So I am using some unique angles so I can create a unique look to this whole frame system. Because this truck is a dually, meaning that's more wider, I wanted to create a ladder rack that utilized all of the space available. And because the ladder rack runs over the cabin, we're going to have a problem. And the reason why is because the cabin is much more narrow than the frame of the dually flatbed. So, um, when designing this, I needed the corners of the front portion to curve inwards in order to avoid hitting a branch or of a tree or a certain design of a gate or anything of that sort. Alright, so at this part of the project, I have cut all of the aluminum pieces that will make the frame of the top portion of the ladder rack. Right here, I'm putting everything in place on the floor so I can start measuring and forming my angles so I can start cutting the sections and start forming the whole frame. Um, at this point, I'm working on the front section of the frame. And this is the same part, but with all the angles cut and placed together. And I gotta say, I'm very surprised how well those angles started to fit. And here's the same section back to the main frame to have an idea of the whole layout. Alright, so now for the fun part. So this is the first time using this welder to weld aluminum. And to be honest, I was kind of nervous for this part because the whole project relied on the ability for me to weld two pieces of aluminum together. And if the fusion of these two metals were successful and possible for me to carry on throughout the whole project. And here's me testing my welds for the first time, and looks like it passed the test. Now, after getting everything tacked in place, the next step here is to start welding everything fully. And I'm glad that I started with this component of the frame of the ladder rack, being that it is um, two separate pieces that could be easily joined together to form the structure. I could easily move this structure around, be comfortable learning how to weld aluminum, because as soon as this structure becomes more larger, um, it's going to take too much space in my garage and won't have the ability to flip the material around to find the best position. I have to work with what I have and try my best at it. And just adding the components that run perpendicular to the frame, you can see the scale of this ladder rack. The dimensions of the ladder rack is 7 feet wide by 12 feet long, and I decided to go with this dimension because uh, by going 7 feet wide, it gave me 8.5 inches on each end to install some hooks for some extension cords. And as you can see here, the whole frame of this ladder rack took all the space I had in the garage. And here is the main frame of the ladder rack, and as you can see in the front, it curves inwards. That's what I was referring to. And here I decided to run some more support beams to run a gangway that ran to the middle so I can walk on top of the ladder rack like a platform to grab ladders, pieces of wood, material. By going through this route of installing this gangway, it required a lot more work. A lot more pieces has to be cut, had to be tacked and welded. But this was a safer alternative, and it gave me a lot more reach around space to grab material. So right now I am tacking everything into place. And with that being said, I would like to take a moment to talk about the welder I'm using. So I'm using a 221 invertig AC/DC HTP TIG welder. So I am using the AC setting of this welder. This is the actual first time using this welder with the material aluminum. Never had the opportunity to TIG weld aluminum before with this welder because I've been busy. But with this opportunity came for this project, and knowing that this would be a great learning experience, I wanted to test my TIG welding capabilities. And as you can see here, I ran some lateral support beams that ran parallel to the sides. Um, this was somewhat overkill. The quarter-inch rectangular tubing was enough for this project, um, but I decided to go with this route, give it some strength, some more longevity, just in case, because this is a massive project and I wanted to do it right the first time. So, yeah. And as you saw earlier, I was heating that corner. Um, the more you weld and the faster you weld, especially in those corners where multiple pieces of aluminum join together, you see that you require a lot more heat to initiate the weld. Unlike steel, where heat is usually collected at one pinpoint location, aluminum and its heat constant likes to transfer evenly throughout the whole piece, so you have a harder time heating up the piece. So it requires more time and effort to prep the area for welding. And with all this heat, there was a point where the torch of the TIG welder was unbearably hot. So I had to cool it with a towel that was sitting in a ice bath. Um, didn't really had a cooler system for this torch. And at this point, I am done welding the whole frame. The next step is to cut the aluminum for the gangway. So I'm using a 1/8 inch diamond plate for the whole platform. It is pretty heavy stuff. Give it a lot of weight, but you got to think about it. It is aluminum, so it is kind of malleable, and you're gonna be walking over this with some weight, carrying ladders and pieces of lumber. So I need it to be as strong and sturdy as possible. And right here, I am welding the plate to the center beams, and it is kind of tricky welding these corners, especially these T corners. It takes a lot of practice. Initially, I found myself dipping my tungsten to the aluminum welding pool, which contaminated the whole piece. So I had to resharpen my tungsten, and I gotta say, these T corners took a lot of effort. I had to resharpen a lot of tungsten to get it right. A lot of trial and errors. But at the end, I became very good at this type of position of TIG welding. And yeah. So right here, I'm getting everything prepped and ready for the top portion, trying to combine everything together, weld the whole gangway piece to the frame. These are the mountain hooks I referred earlier for the extension cord. They run to the side of the whole frame. And as you can see here, I have completed the whole base frame of the ladder rack. So everything is welded completely. Took a lot of welding, took a lot of filler rod. But I can't complain because everything is incredibly strong. Uh, I think I made a roll cage for this truck, to be honest. And I'm so glad that I overbuilt this whole frame. I am more than confident that this whole frame will not fall apart. It's gonna be here on on this truck for a long time coming. And this is me on top of the walking platform, also known as gangway. I can just imagine how much people can stand on this without even any sort of flex or torsion of the frame. This whole top portion is very rigid, very strong, and it looks very impressive. I'm very happy with the results. As you can see, these are the side hangers for the extension cords that I'm gonna put. But yeah, it's looking very good. Decided to put these corners there to give it a little bit of a design. The whole section right there is all welded, including the back. I mean the underside. But very sturdy, very strong, very happy. All right, so for now, the next step of this project is to create the legs for the ladder rack. I already made the top portion, now it's to make the bottom portion. Here's the pieces for the legs. So unfortunately, I did not record this part of the project. So what we have here are the legs for the ladder rack. So they appear to be at a certain angle, and what I wanted was the legs to flare up at a certain degree to give it um, some space for the extension cords to hang in the side, and also to give it a nice look. Also, with the lateral force, I felt like this was the weakest point of the whole structure, so decided to add these plates to give it strength. You can just imagine these are your knees, and you have every components of your knees, your tendons, your meniscus, that gives it the strength and mobility. Because believe it or not, this is going to flex quite substantially, so you want to support it as possible. So, at this point of the project, I am going to cut out the horizontal mounting plates that will sit on top of the flatbed. Earlier, you saw me welding the legs for the ladder rack. So, the whole plan here is to create a a little mount of the bottom of the legs to bolt to the frame of the flatbed. Essentially, I'm creating a horizontal piece which will have holes where bolts can go through and be bolted to the frame of the flatbed. And in order to create a strong joint, I'm gonna put a vertical piece, which is gonna be this triangle piece here, that will act as a gusset to the leg, so I can weld everything together to be as strong as possible. So what we have here are the finished products of the legs of the ladder rack. I have finished welding the whole components of the whole system. What we're working with are half-inch aluminum plating that will run horizontal. This is where the legs of the ladder rack will sit, and also this will make the whole system be bolted to the flatbed. We also have quarter-inch 12 by 12 gusset plating that will give it tremendous strength. So we'll have no problems in the lower portion of this ladder rack system. However, when we're going to attach the legs to the main frame of this ladder rack, we're going to have to create gussets to support the upper component as well. In this part of the video, I'm adding the legs to the upper component of the ladder rack. The next thing to do is to tie everything together by adding gussets. This would give it zero possibility of the whole structure from failing and collapsing. So, congratulations. We have went through and we have seen the whole process of the whole ladder rack built. I'm very happy with the whole build. It it is quite heavy, to be honest. Moving it from my garage to this part here of my property was very challenging. Good thing I had help with my family moving it. But man, isn't this a piece of art? I am so happy. And here I am. This is me installing the ladder rack. I had to use a skid steer to pick it up because, like I said, it's heavy. But this is basically the whole completion of this ladder rack portion. Here you can see here it fits quite nicely between the two boxes. And the next step is to create those drop sides. You see how right there I'm using a temporary pieces of 2 by 8 to just hold the stuff together, and right here I'm getting started with the whole drop sides. Let's get to it. So what we have here are the structural components of the aluminum drop sides. There you see the stainless steel hinges bolted to the frame of the flatbed and bolted to the frame of the aluminum structure. We also see the locks for the whole drop sides, and here we see the whole structure or the aluminum drop sides folded away, so we will have available space to put pallets of material whenever we need it on the fly. The next step from here is to put the plating on the drop sides, and we will call it a day. That'll be it. So here I'm getting started to finishing things up, tie everything together to get this truck to work. From this point, a year has passed since the completion of the project, and I really want to take the time to inspect and to see any issues that came up throughout the year. And after a year in service, the whole structure rigidity is intact. There is no breaks in the weld areas. The stainless steel hinges have no rust in the joints, and the locks that are attached with rivets to the drop sides have zero play. Everything is working as it should, and I am impressed. The ladder rack structure is holding up uh, firmly, and it is become the most helpful thing in this truck. Um, just putting pipes, ladders, uh, pieces of lumber, you name it. It's just been another, to be honest, another flatbed platform. So essentially, I have two or double the area of this flatbed. So I'm running probably 22 feet long a flatbed. Essentially, that's how it feels like because it gives us just so much space. And this whole project has been just so helpful at work and just makes everything so easy. And this whole project was a new chapter for me because this I never did anything in this magnitude. My typical welding, was just steel, fixing little things here and there around the house, some tools here. But yeah, but doing this and learning throughout the process was a big confident booster, and just a big learning experience, and that I really appreciate me taking the time and just enjoying the whole process because for all this hard work, it did pay off. I got a lot of compliments at work, places I stopped by, gas stations, places where people can see it and close up. Ask me questions and are surprised to find out that I did the welding and just are just amazed, and it gives me a sense of gratification, and I did enjoy the whole process. I do like this type of welding. I do stick welding as well. I tried that before, MIG welding as well, but this is the first for TIG for aluminum and stainless. But yeah, man. I just I hope I can do more projects like this. Hopefully I can create something for another truck or or maybe a toolbox for the back undercarriage of the flatbed. You never know. See what happens. But yeah, you know, uh, more about this here. We can just see how intact it is. No failure whatsoever. Here with those gussets, I was kind of hesitant because they're pretty thick. I believe they're are half an inch thick of aluminum, and that took a lot of heat to weld. So I'm surprised how well it just blended in. And just look at those beads right there. Just give myself a pat on the back. But yeah, but yeah, this was a great experience. But yeah, it looks great, and thank you guys for staying tuned and being a part of it. Thank you very much, and I hope to see you guys another time. Thank you.